Welcome to homework.
We have the bottom bar here. We know that each bar is static equilibrium. So in order to find, to find force sub CD, we can apply the sum of torque. This will equal 0, and this will equal m sub d g x sub d minus m sub c g x sub c. And so m sub c would be equaling m sub d times x sub d over x sub c. This is equaling m sub d multiplied by 17.50 centimeters divided by 5.00 centimeters. This is giving us 3.50 m sub d. And so we can apply the sum of forces in the y direction. This system has translational equilibrium in the y direction, so this is going to equal 0. And we can say that this is equaling force sub CD minus m sub c times g minus m sub d times g. And so we find that force sub CD is equaling 4.50 m sub d times g. And we can keep in mind this relationship. We then have the middle bar here. Again, we're going to apply static equilibrium. Sum of torques is equaling 0. This will equal force sub CD x sub CD minus m sub b gx sub b. We find that force sub CD is then equaling m sub b g times x sub b divided by x sub cd. And we can say that here 4.50 m sub d g equaling m sub b g x sub b divided by x sub cd. And so we can say that then m sub d is equaling m sub b x sub b divided by 4.50 times x sub cd, and we can solve. So this would be 0.748 kilograms multiplied by 5.00 centimeters divided by 4.50 multiplied by 15.00 centimeters. And so we find that mass sub d, this is equaling 0.0554 kilograms. We can then say that m sub c is equaling 3.50 times m sub d. This is equaling 3.50 times 0.0554. This is equaling 0.194 kilograms. So we find mass sub d here, mass sub c here, and then we can apply the sum of forces in the y direction. Or sum of forces in the y direction equals force sub b cd minus force sub cd times c minus m sub b g. Now here we can say that then, my apologies, this is just the sum, the forces, so we don't have to multiply it by any length. Force sub CD and then minus m sub bg. And so this is giving us that we know that this is equaling 0 because we have translational equilibrium in the y direction. And so force sub bcd, this is equaling essentially 4.50 m sub d plus m sub b times g. And so we can just keep note of this relationship. Now we have the top bar here. We can that here applying the sum of torques. Again, this equals 0. And this would be m sub a times gx sub a minus force sub b c d times x sub b c d. And so mass of a would equaling 4.5 m sub d plus m sub b times gx sub b c d. This would be all divided by gx sub a. And so m sub a is found to be 4.50 m sub d plus m sub b. The gravity cancels out, and this would be multiplied by x sub b d divided by x sub a. And so we can solve. This would be 4.50 multiplied by 0.0554 plus 0.748 units here, kilograms, multiplied by 7.50 centimeters divided by 30.00 centimeters. And we find that mass sub A is equaling 0.249 kilograms. This would be our final answer. That's the end of the solution. Thank you for watching.